I presume we want to do all of these from number 1?
Yeah, I do have these sheets that we did in class today about different types of statistics.
Which do you want to go over? You need to send me what your prior.
I sent you those. That was my homework for tonight.
Let me make sure. Let's see.
I think it's already on your screen.
Oh, oh yeah, there's one more page. Okay. And I haven't opened it. I did look at the other page, but I just don't have it opened. Well,
Right.
let's start from the beginning. So, what's number 1?
Hold on, I'm not sure.
The
Is
sample.
it the parameter?
The sample.
The sample.
In other words, we have 320 million people that live in the United States. But if I sample 1 million of them distributed, then I'm going to figure out stuff that is very, very accurate in representing the entire population. In other words, if I sampled 1 million people and found out that 52% of the people were women and 48% were men, I could fairly accurately say that in the United States, 52% of the people are women and 48% are men, even though I didn't sample the entire population. I just did a portion of it. Because it's rare that you can ever sample the entire population. When you do presidential polling, in other words, in this last election, they don't poll every person in the United States. That's impossible to do. So what they do is they take a sample. They maybe poll 1% of the people. And then whatever that 1%, whichever way they go, they can make the statement that statistically that's very representative of the entire population. So this concept of taking a portion of the population, that's a sample.
Okay.
Number
Do you want me to send you the homework I did last night? It was over the, because these are just different types of samples.
you send me whatever you need to, Emma, whatever you want to go over. It's your choice. I have no idea which is most important in your priority list. I really don't, because I don't know if you know these questions or if you don't know the others, or so you have to make the choice as to what you want to go over during a session. Go ahead and send me whatever you want. It doesn't take any, there's no problem in sending stuff, and I'll just open it as needed.
Well, do you have your Algebra 2 book or no?
I do.
So, the homework last night was on page, hold on. It was on page 749.
Okay, let me go to that. All right, and this is where number 16 says, what's the probability that 15 or fewer students are colorblind?
Yeah, and then the problems were 2 through 9, 19 through 28, and then 48 through, or 38 through 43.
Would you rather cover that rather than this stuff that we're looking at?
Yeah, because I feel like it's easier to distinguish what different types they are rather than
You're right. We could go through
the graph.
Quick, yeah. Basically, the parameter would be how many women are in the United States. A statistic would be, well, we sampled so many, 1 million of them, and 52% were women. So,
yeah. Because I'm confused. I didn't know that the graph that they normally use, the, what's it called? Hold on, let me look back at my notes.
the normal distribution,
Yeah, I didn't know that could be used for all of them, so I never could figure out how to find the percentages.
all right, let's look at number 2 on page 749.
Okay.
A normal curve is symmetric about what x value?
The mean.
Yes. In other words, a normal curve looks like this, and this peak is the mean, which I can write as x bar.
Mm-hmm.
Okay. Number 3. What percent of the area under a normal curve lies within 1 standard deviation of the mean, and in 2 and in 3? What they're basically saying is if this point here is the mean plus 1 standard deviation,
Uh-huh.
point over here is the mean minus 1 standard deviation. You with me?
Mm-hmm. Yeah.
And what the statement I can make is the area right there is
Mm-hmm.
what percent of the area of the entire curve, under the curve. In other words, the area under the entire curve would be all the area under the bell.
68%.
Correct. 60%.
And then 95.
And then, hold on, let me use a different color for that.
Okay.
Because green is going to be x bar plus 2 standard deviations. And this
I
green
think
is going to be the
you're
mean minus 2. What's up?
I think you're doing it the wrong way. 'Cause here,
No, I'm doing it the right way. I actually did these exact problems last night.
'cause on my, here, I'll send it to you.
Okay.
In my packet, it has it horizontally.
Well, trust me, this is the right way.
Really?
Yep.
Is
Look down
that
at the bottom of this page. See how they have those 4 graphs? See how they've labeled the x-axis?
mm-hmm.
That's the way I'm doing it.
Okay.
Okay. Also on the other page, 748, it's a horizontal graph and they're just breaking the area up into different sections.
Okay.
Okay. All right. So the area in the red was 68% of the total area. What about the area from the green? What percent of the total area is that?
97.7.
That's 95%.
Oh, that's what I meant. That's the next one.
Right. Okay. And the next one comes at x plus 3 standard deviations and
Uh-huh.
x minus 3 standard deviations. That's going to be the blue.
Yeah, that's the 99.7.
Right. Now, if I look at this entire area, that's going to equal the 99.7%. So when you go 3 standard deviations of either side of the mean, you're pretty much covering all of the area under the bell curve. There's a little bit. There's still 0.3% between over here and over here, but we pretty much got it covered by going out 3 standard deviations.
Yeah.
Okay. All right. Let's go back and So we've answered number 3. Okay. Now let's look at number 4. The mean is 10.
Mm-hmm.
And one standard deviation is 1.
That's the part I don't get.
Okay. Well, notice that this point, 11, and this point, 9, are within one standard deviation of the mean.
Okay.
And what that means is that the area under that curve is 68% of the entire area under the curve.
Mm-hmm.
So their first question is, what's the odds of randomly selecting between 8 and 12? Well, if I go to 8, that's 2 standard deviations. Okay, if I use a different color, in other words, the area between 8 and 12, if I look at all of this area under the bell curve between 8 and 12, that's 95% because it's 2 standard deviations.
Uh-huh.
Now if I were to go to 7 and 13, well, that's 3 standard deviations. Remember, a standard deviation is 1. So if I go 3 standard deviations from 10 in either direction, I'm including from 7 to 13. And
Right.
that is 99.7% of the area under the curve. And when I point to that, I mean all of the area between the green lines.
Mm-hmm.
When I talk about the red, I'm talking about all the area between the red lines and under the curve. And the black is all the area under the curve between the 2 black lines.
What is the, because she has a picture of like 0.15 and then 2.35 on the side, then 13.5 and then 34.
I'm not sure because I wasn't in your class, so I don't know what she was talking about.
You want me to
But no,
skip to you?
I think our best bet is to go through these because you're going to get answers to your questions by going through these problems. Trust me.
Okay.
Okay? All right. So the next one is, what is the odds? And incidentally, the odds of picking a number between 8 and 12 are the same as the area under the curve. So
Mm-hmm.
the area between 8 and 12 under the curve is 95%. That's the odds of picking a number between 8 and 12. As long as 10 is the mean.
Okay.
I'm going to draw the mean back in there because we're going to need it here in a minute. Okay. Now, number 6, a little harder. They want the odds of landing between 8 and 11. Well, in order to do these kind of problems, you have to think of splitting up your bell curve in half. Half of the area to the right of 10 is half, and the area to the left of 10 is the other half. You with me?
Yeah.
Remember that the total area under the curve is 1. So all the area to the right of 10 is 1/2. All the area to the left of 10 is 1/2. Now, tell me what the area, I'm going to number these. And when I number it, I mean between the median and 11. In other words, between 10 and 11. What's that area?
Um, 34.
Yep, you got it. What's this area between 8 and 10?
34.
Oh, that's 2 standard deviations away.
Oh,
So it's half of the 2.
13 and a half.
It's half of 95, right? In other words, if the area between the 2 red lines is 95%, well, then the area from the median to the 1 red line is half of 95%. So if I write in red area number 2, you know what area I'm talking about?
Uh-huh.
The area only between 8 and 10. Well, that's going to be half of 95%. So area 2 is going to be 47.5%. You see why?
Uh-huh.
Only going to be half of 95% because I'm only talking about the area between 8 and 10. But then I've got to add to it area number 1 between 10 and 11. Well, area number 1 is 34%. So the area between 8 and 11 is the sum of those two, 81.5%. That is the area from there to there.
Mm-hmm.
You with me?
Yeah.
That's the way you have to do almost all of these. All of the remaining questions, you have to be able to split up these areas into half of the area. In other words, the 3 key numbers that we have, 68% for 1 standard deviation, 95% for 2 standard deviations, 99.7% for 3, that
Mm-hmm.
applies to either side of 10. But
Yeah.
if I'm only looking for half, in other words, if I want to know, in other words, from 9 to 11 is 68%. Well, what that means, since it's symmetrical about 10, is that from 9 to 10 is half that, 34%. And from 10 to 11 is 34%. With me?
Yeah.
Okay. And that's the way I got the area of number 2 also. I know that 95% of the area lies between 8 and 12 because that is the mean plus or minus 2 standard deviations between 8 and 12,
Mm-hmm.
which means that between 8 and 10, since it's symmetrical, it's half of 95%. So that's where I get my 47.5%. And then if I want the area that they're asking about between 8 and 11, I've got to add those two areas, 1 and 2. And that's where I get my 81.5%.
Okay.
Okay? All right. Let's go on because all of these are kind of the same structure.
Right.
At most 10. Well, at most 10 means this area, right?
Would that be, hold on, let me see.
Well, look at the bell curve. The most important thing you can understand about the bell curve is that it's symmetrical about the median.
Uh-huh.
Well, if
Would it be
it's symmetrical
50?
about the median, what is the area to the left of 10?
50?
50%. In other words, if the area under the entire curve is 1, then the area that I've shaded in green is 1/2. And that
Uh-huh.
makes the odds of picking a number that's at most 10, 50%. In other words, remember the probability is always the area under the curve. And we know how to figure out the areas under the curve as long as they tell us the mean and the standard deviation. Then we can chop this curve up into precise measurements based on standard deviation and figure out what the area is. Not all bell curves look the same. Some look like this, some look like this. And it kind of matters as to what your standard deviation is. Okay? So you always need the mean and the standard deviation, and then you can answer all of these questions that we're dealing with. At least 12. What part of the curve is that? Let me erase all of this so I don't. At least 12. Your book's not going to tell you. You have to look at the curve and imagine what numbers are they talking about when they say at least 12.
So would it be 63.5%?
Give me any. Well, first of all, you have to define what area of the curve they're talking about. So I want you to tell me what area of the curve they're talking about. Is 13 at least 12?
No.
Sure it is. 13 is more than 12. At least 12 means it has to be 12 or more.
Oh.
So 13 qualifies, 14 qualifies, 15 qualifies, 11 does not. So the area that they're talking about is that area.
16?
Where'd you get 16?
Because on this graph that she has it horizontally from...
I can't help you with that. I gotta go with the book. I don't know what she's given you. I don't want to try to figure it out.
Do you want me to send it to you? It's just a chart of them.
Go ahead if you want, but I don't want to leave this material. This is the proper way to look at normal curves, normal bell-shaped curves. This is a great page for statistics. So if she's somehow changed it to make it horizontal, I'm not sure I'm going to understand it. And we only have 30 more minutes, so I don't have a lot of time to try to understand it, if you know what I'm saying. I understand this. This is the way that's in your book. Let's stick with this method.
The interesting thing is that the way I've figured out the answers so far, the different way has been coming up with the same answers, so I figured it still would, but it's not.
That's fine, but please understand I am not a statistics tutor. So
no, I know.
It's all I can do to understand this part. So I don't really want to try to understand somebody else's new outlook on it. Especially since we can come up with all of these answers doing it this way.
So would it just be...
Well, it's a process. It's not, you're not going to, when I say what's the chance of being greater than 12, you can't come up with that number without going through the process. You have to figure out what the rest of the area is and subtract the rest of the area from the number 1. Okay? Here, let me explain it.
I think...
What is the area to the left of 10? If the area entirely under the curve is 1, what's all this area to the left of the number 10?
It's 50.
1/2. Like I said, if the area under the curve is 1, then the area to the left of the mean is 1/2. Okay? Now, let's figure out what this area is. That's 2 standard deviations away from the mean, but it's only half of it. So what percentage, and this equates to 50%. I'll write it as 50%. So we got 50% covered everywhere to the left of 10. Now, what percent of the curve is between 10 and 12?
50?
No, that's above 10 would be 50. In other words, all of the curve to the right of 10 would be 50%. But we know what percent is between 8 and 12. What percent is between 8 and 12? 2 standard deviations.
Would it be 50% then?
Hold on. It's 95% when you are within 2 standard deviations. So if I look at this entire area, there's the area within 2 standard deviations. That's 95% of the area under the curve.
All right.
Now tell me how much is in just half of that. What's half of 95%? Remember, this curve is symmetrical about the line x equals 10.
47.
47.5% is that area right there. Okay. Now, the area that we're talking about, there's 50% under the curve. There's another 47.5%. So what's left over?
Hold on.
2.5% is the area that I've shaded in black. 2.5%. Because what it is 100% minus 50% minus 47.5%. Well, that comes out to only be 2.5%. In other words, not very much. So the odds of picking a number greater than 12, in other words, at least 12, which is what the book says, only 2.5%. And that's the way you have to do these. By knowing not just how much of the curve is between 9 and 11, that's one standard deviation, that's 68%, but knowing that how much of the curve is half of that. In other words, how much of the curve is in the area that I've labeled 1? Well, that's 34%. In other words, you have to be able to chop this bell curve not just up into 1 standard deviation or 2 or 3, but you have to do half of each of those also. Because a lot of times, these problems they're giving you, especially the graphs down below, that's the only way to do them, is to know what the area in the bands that they're talking about. And notice how they've labeled the horizontal axis. They've got x minus 1 standard deviation, and then they got x plus 1 standard deviation. So that means that on number 22, the area of the white in the middle is 68% of the area under that curve.
Okay.
Okay? All right. So we got one more to do here. At most 9. First of all, what does that mean? What kind of numbers are they talking about? To be at most 9. That's the first thing you have to be able to figure out.
From 0 to 9.
Okay, good. So they're talking about this area right there. Okay? From 0 to 10 is what percent of the curve?
50.
Okay. What is the area in section 2 that I just labeled? From 9 to 10.
34%?
Okay, so if that's 34, and this is 50, the whole thing,
Is
what is the
16.
red? Exactly. That area is 16 because 16 and 34 add to 50.
Right.
Okay? All right. Now,
Okay.
um,
Problems.
same subject and go down and do 19 through 22.
Yeah, can we do, because I think I did those ones.
Okay?
Well, actually we can do a couple of those.
Okay? You have
Uh,
to understand the method to do them. Once you understand the method, then whatever combination they throw at you, you're going to be able to do. But you have to understand the method.
right.
So on number 19, what is the answer?
50%.
Correct. Number 20, what is the answer?
Uh,
Not as obvious, is it?
is it 16 again?
I don't know. I got to go through the method. I can't answer that without going through the math. Okay? First of all, what is the area of section 1 again?
34.
Okay. What is the area from 8 to 10?
That was 47.5.
Actually, we don't need that. You're right, but that's not what we need. What we need is the area from 7 to 10. Notice that 7 is my mean minus 3 standard deviations.
Uh-huh.
13 is my mean plus 3 standard deviations. So if I can figure out the area from 7 to 10, then I'm going to subtract the area from 9 to 10, and I'll end up with the area from 7 to 9, which is what they're asking on question 20.
Mm-hmm.
So what's the area from 7 to 10?
Is it 15.85?
99%. The area between the two green lines from 7 to 13 is 3 sigma, which is 99.7%.
Oh, okay.
What is this area?
Mm,
That's half of 3 sigma. In other words, that's 3 sigma only to the left of the mean.
would it be 49?
Yes. So from 7 to 10 is 4, let me put it in green, it's 49.85%, right? That's that area. Now, the area they want is this area. Well, notice that if we take 49.85 and subtract 34, we get the blue area. So what's the area of the blue?
Are we subtracting the 2.5?
No, we're all shaded problems. Whether you're talking geometry or algebra, all shaded area problems tend to be subtraction problems.
Mm-hmm.
Well, we know the area of the green from 7 to 10. That's 49.85%. We know the area between 9 and 10. That's 34%. So to get the area between 7 and 9, I'm going to take the area between 7
Subtract of
and 10
34.
and subtract off the area between 9 and 10.
So 34?
So the answer is 15.85 is the area between 7 and 9.
Okay.
Okay? All right. This is actually, the reason I was so insistent upon staying on this page is because this is really important stuff for statistics. And I don't know what your teacher has done, how she's changed it around to figure it out. I don't know. But I know how to do it this way.
Okay.
So now let's look at 21. 21 is the blue area, or the blue area, I'll use blue, that is to the right of 2 standard deviations, right? 12 has 2 standard deviations.
So is that the 2.5?
No, 2.5% was to the right of 13.
Oh, so that one is 16.
Well, you can't do it. You don't know what it is. You have to go through the process again. Okay? In other words, what is this area right there? I got to add that area to this area and subtract that number from 1. So what's the area in red?
So that's 50.
What's the area in green? 2 standard deviations, but only half of it. You're right. It is the same number. It is 2.5%. But I didn't recognize it because I hadn't done the math. Okay, the area in green is half of 95, which is 47.5%. And the area in blue is everything that's not green or red. So the area in blue is going to be 100% minus 97.5%. And that's where we get our 2.5%. Okay? And so for 21, it's 2.5%.
Yeah.
All right. Turned out to be the same as the other.
Yeah. Do you want to look at the picture I sent to you to see how I'm getting it?
Sure. Let's see if I can figure out what.
Because I'm getting it. It's kind of easy, but I don't know why they teach it differently at our school.
I don't either. Yeah, normally I would not have a problem with that. If it was anything else other than statistics, I'd be fine with different methods.
Yeah. Yeah.
But the reality is that I'm really not a statistics tutor. So I have to kind of look at it in a different way, in a way that I understand it. It's the same way.
See, there's the 34, and then 13.
The 34 plus 34, that's where you get your 68% between and 1 standard deviation.
And then it splits it up again to 13.5.
Right. If you go 2 standard deviations, then you've got 47.5 plus 47.5. That gives you your 95%.
Yeah.
So the way she's done it in these graphs is exactly the way I've been doing it. Nothing different at all. It's exactly the way.
You just have less segments.
No, I don't. I had the same number of segments. Notice.
But you numbered it differently.
Well, segment 1 is the same as her segment. That one right there, the one that's got 34% in it, that's my segment 1.
You just have been numbering them differently.
I've drawn dotted lines to represent each of these segments. In other words, the total green area is half of 95%. So that'd be 47.5%, which you get from adding 37 to 13.5.
All right.
All right. I kind of see what's going on now. You've memorized these 2 tables. And when they ask you a question, like is in the book, is all you have to do is add up. So you see question 22, you add that 13.5% to the 13.5% that's on the other side to come up with 27%. All right. There's nothing wrong with doing it that way. That's probably the best way to do it. I kind of was starting from scratch, but
Yeah, it looks like they try to make it easier for us.
well, and they do, but I felt that it's really important to understand where they get those numbers from.
Yeah.
In other words, one standard deviation away from the mean covers 68%, which means half of it's 34 and the other half's 34. And that's
Mm-hmm.
where they get the numbers they're putting on here. These are the same. The graph on the right is exactly the same as the graph on the left.
Yeah.
It's just they've chopped it up and labeled each section as either 0.15 or 2.35 or 13.5 or 34. All right,
Mm-hmm.
I get it now as to why you were finding my original technique confusing.
Yeah, I understand it now.
Okay,
What you
good.
do.
I was doing the same that they're doing here. It's just that I was figuring it out rather than reading from a table. But
Yeah, I just got confused a
in
bit.
order to generate this second graph is generated entirely from the first graph. And that's what I was doing, was starting with the first graph and then figuring out what each of these areas were for each panel, which is what they've done here.
Mm-hmm.
All right. So we got 15 minutes more. Do you want me to blow this up? Are there questions on this one that you need answering, or doesn't look like I have anything more than just these two graphs?
Yeah, those were just
Yeah, and the
the
questions above
problem.
answered. Notice that when they say the area lies within one standard deviation, that means
Uh-huh.
either side of the mean. In other words, within one standard deviation means the mean minus the standard deviation to the mean plus the standard deviation. That's where they get the 68%, is within one standard deviation. That's actually a distance of two standard deviations.
Mm-hmm.
And the 95% is within two. So the total distance of that is actually four standard deviations, because we're going from -2 to +2.
Mm-hmm.
The same with the 99. That's anything within three standard deviations, which means I'm going from u minus 3
Mm-hmm.
standard deviations to u plus 3. All right, so there's not much else to look at on here.
Mm-hmm.
Let's go back to the questions since we have a little bit of time left.
Mm-hmm.
So you're going to be able to do 19, 20, 21, and 22 the easy way.
Mm-hmm.
Just to read it off of your chart on the right from the previous page.
Mm-hmm.
What else do we want to do in the next 13 minutes?
There was also just, I mean, I guess we could do the first two sheets I sent you, since the rest of the homework assigned last night was just like what we went over for the past
Yeah,
40
those
minutes.
are not going to be hard to do because I think most of them are just word answers.
Right.
I actually always hate when I see math pages that have nothing but writing on them.
Yeah.
Math pages should not have nothing but writing. Math pages need numbers and equations.
Yeah.
See a math page? Notice there are no numbers on this page until you get down to this question, number 11. Everything else is a word. Well, I might be wrong in saying this, but what that means to me is that the person that made this sheet up is an English teacher, not a math teacher. Because no math teacher would put a page full of nothing but words. I just don't believe they would. Okay?
But
So,
what I do exercise 7 through 10?
okay?
Oh, or we could do
Populations or samples? Number
7.
7.
Okay. So the number of high school students in the United States is a sample.
Population. In other words, they're saying the total number of high school students in the United States. They're not approximating that. They're counting them all up. And when you count every single one, you're getting a population. If I only sampled 100 high school students in the United States, then I would be talking about a sample of high school students.
Right.
Okay, so 7 is a population.
Okay. It's a sample.
That's a sample. You're only noticing the color of every third car. You're not writing the color of every car. In other words, if you're only doing a portion, that's a sample. About number 9.
A sample?
Okay.
Or would it,
Yep.
yeah.
Number 10.
The age of each dentist, and that's a population?
A population, because in order to answer that, you would have to actually talk to every single dentist and figure out their age, and you'd put it in a table. But it wouldn't be a sample. The thing about statistics is they rarely do populations. If you wanted to know the age of each dentist, you wouldn't really have to call up every dentist in the United States. You could probably call 10,000 of them.
Mm-hmm.
That would be a large enough sample that it would be statistically very similar to if we did all million of them. Let's say there are a million dentists in the United States. Well, if I really wanted to know their age distribution,
Mm-hmm.
exactly, well, I'd have to call every one of them up. But nobody has those kind of resources that they can afford to call every single dentist up.
Yeah.
What they'll do to get a representative, in other words, if you want to know what your median age is for dentists, you don't really have to get the age of every dentist. You could call 1,000 dentists and
Mm-hmm.
come up with a bell-shaped curve based on the 1,000 that you called. And maybe you discover that the median age is 45. And you would also discover what the standard deviation was. Maybe the standard deviation is 2 years or 5 years even. Okay, so that 68% of the dentists would be between the age of 40 and 50. You understand where I'm going with that?
Yeah.
Okay. So when you are talking bell-shaped curves that are normal distributions, there's only 2 things that determine the shape of that curve. And that's the median,
Mm-hmm.
or the mean rather, excuse me, and the standard deviation, because that will totally dictate the entire shape of the curve. Because remember, within 3 standard deviations has to be 99.7% of the area.
Mm-hmm.
Okay, so in other words, I wouldn't be able to draw this just any way that I wanted. If you told me the median is 10 and standard deviation is 1, well, that kind of dictates my curve's going to look like this.
Mm-hmm.
Because if this is 10, I got to have 99.7% of the curve between 7 and 13. So I can't draw that curve any old way. In other words, I can't draw it like this. There's no way that 99% of the area is between 7 and 13.
Yeah.
So the mean and the standard deviation dictate how this curve is going to look.
Mm-hmm.
But the very first thing you should do is draw a vertical line through the mean. Now I know that 1/2's over there and 1/2's over there.
Mm-hmm.
And then I can figure out how much is in each of these bands, these vertical bands that they are putting, that your teacher put on those charts and that we see on page 749.
Mm-hmm.
All right, let's go back and look at some of these other questions.
Should we do 11 through 14?
Yeah. Well, we only have 6 minutes. We'll try. Determine whether the numerical value is a parameter or a statistic. The average annual salary of some physical therapists is $76,210.
Would that be a no?
Hold on.
That'd be a...
I'm going to have to look it up because I don't know. But I do remember when I was looking at this chapter that there's one page that defines the difference between a parameter and a statistic. I just got to find it.
Okay.
Assuming I can find it. I'm not sure I can.
Do you want me to read you what mine say?
Yeah. What page is yours on?
It's in my course pack, so you don't have it.
It's not in this book, huh? Because I was looking at this chapter, and they have one thing that definitely talks about the difference between a parameter and a statistic. Yeah, what does your book say? Or what is...
It says a parameter is a numerical description of a population, and then a statistic is a numerical description of a sample.
Okay, so what's number 11?
A
statistic, because it's not based on all therapists. Had they surveyed all physical therapists in the state, that would have been a parameter.
Mm-hmm.
But the fact that they only did some makes it a statistic based on the definition you just gave me.
Mm-hmm.
Now, 12. In a recent year, 53% of the senators in the United States Senate were Democrats. Is that a parameter or a statistic?
A parameter.
Correct. Because they know the exact distribution of the Senate. That means there's 53 senators that means that 53 of the senators are Democrats and 47 are Republicans.
Mm-hmm.
All right. Let me open this page here. In other words, when you can figure it out exactly, then it's a parameter. When you are basing it on a small sample,
Mm-hmm.
then it's a statistic.
Mm-hmm.
I can't read 13, so let's do 14.
Okay.
A survey of U.S. adults found that 10% believe that a cleaning product they use is not safe for the environment.
That'd be a parameter?
Well, that's what I would say, is that is a parameter. Question is that presumes that they've surveyed every adult in the United States, which is kind of hard to believe, right? So they probably came up with that number based on a sample. Like I said, you can't really survey. There's 320 million people in the United States. If they could have surveyed every single one of them, then they would have gotten the election polls right. They would have known that Donald Trump was going to win. But they couldn't do it. You don't have the resources to survey every voting adult in the United States. what you can do is take samples. And
Right.
when they take samples, historically, these are very, very representative of the final actual results when everybody does vote. But there's usually like a plus or minus 3 to 6% built in. If you're basing a prediction of all adults based on a sample of like 5% of them, then you're dealing with a statistic, not a parameter. But they didn't say that. The way this question is worded, it makes it look like somebody surveyed every adult.
Yeah, they must have
10%,
broken.
they try to make you think that maybe they did a 10% sample, but that's not what the 10% means. It means that had they surveyed every adult in the country, 10% of them would believe that a cleaning product they use is not safe for the environment. So if you actually could survey all of them, 10% of them may have this belief, and that would be a parameter. But if you only sampled 5% of the adults, and of those 5%, 10% had this belief, then you would say that is a statistic.
All right.
All right, Emma, I have a 5:30 that I have to go to. But
Okay.
I'm glad that you've got your tablet working, because this is the best we've done online in terms of audio and everything else. So you're going to be able to take that tablet when you go to your dad's?
Yeah.
Okay. So from now on, I will not call you. I will text your phone the meeting ID number.
Okay.
That's all you need. In other words, you know how to open it and input
Yeah.
the ID number if I've sent it to you. And
Yeah.
that's what I do with most all my students. The only time I call is at the very first one, just to make sure you got the software installed properly.
Okay.
Okay? All right. I will talk to you next Thursday, Emma.
Thank you.
You're welcome. Bye-bye.